Welcome to the Department of Renewable Resources Seminar Series for January 26, 2012. Our speaker today is Dr. David Chanasyk, Professor in the Department of Renewable Resources at the University of Alberta. His presentation is titled Water Conservation, Motherhood, Myths, Muddiness, and Management.
Thank you, Francis, for that kind introduction, and welcome you all. Thank you for coming. And what I wanted to do was start off by telling you that this won't be your ordinary seminar of PowerPoint. Sorry to disappoint you, but there won't be any. And as well, there's going to be very little in the way of AV, and I do that deliberately just because the topic lends itself to that. It lends itself to my style. But I also want to note that in my numerous years here at the university, I've had two deans that really emphasized public speaking. And the first one was Dean Bentley, and Fred was noted for his public speaking. And more recently, we had Dean Ian Morrison. And I've heard Ian Morrison talk where he was asked with about 6 minutes notice to give accolades about this particular person, and he did a fabulous job. So what I wanted to do was to concentrate on talking to you, which means you will listen and we'll have a fabulous discussion at the end. So nothing in the way of AV. You have from my abstract the highlights of motherhood and myths and muddiness and management, and I'll essentially follow that through. As you're probably aware, there are a lot of books these days that have come out on water. And in fact, it's worth going to Indigo because there are new ones almost every day. What I find is most of them are pretty somber. So they tell us how bad stuff is. And here's the other part that I notice. Some of them have a fair bit of drivel in them. Okay? And what by that I mean is they make statements that are seemingly logical, highly intuitive, but probably even first-year hydrology students could point out the fallacy of their arguments. And to me, that's really, really sad because that's often what the general public sees. Far more importantly for me is the negativism that surrounds the topic. It's sort of doom and gloom that we should have got a ride on the Mars probe because it's probably going to be better on Mars than it's going to be here in short order. So, okay. Now, the other thing as well that's going to be unique in this seminar, it's probably going to be the first one that actually has a rating. It has an SC rating. The S stands for be aware there will be words of sarcasm. The C stands for cheekiness. And you will find that as well. Now, I are both a professional engineer and a professional agrologist. I'm aware of how important it is what we have to say. I'm also aware of how glibness can give a wrong impression. But I'm going to risk it. I'm going to persevere because there's a message I want to get to you. And I think maybe that's one way of doing it. You'll use your handout that I hope all of you are able to get, and we'll actually play Water Manager for at least part of the seminar. The seminar, I warn you, will seem, and it will be, a mishmash. So it's a potpourri of issues because I'm trying to show you how diverse the topics are and how diverse the views are. So it's to reveal the huge diversity of possibilities and to demonstrate that in some instances, I personally think we're flatly going the wrong way. So we'll talk about those. Worldviews. Some of you probably have read stuff from Peter Glick. He's from the Pacific Institute in California. Interesting guy. He's got a blog on it. I heard him recently at the American Geophysical Union meeting in San Francisco, and he was talking about water issues, and he takes a world perspective And he basically says one of our problems is we don't know how much water there is in the world. And my response to Peter is, who cares? I'll give you an example. Levotic in 1970 said that in groundwater there was 4 times 10 to the 6th cubic kilometers of water. That sounds like a big number. He could have said it was times 10 to the 4 or 10 to the 8th. It probably wouldn't have made any difference. One interesting comment that Peter has brought up is the idea of peak water. He says it's akin to peak oil, so that we have, in essence, peaked in our use of water and that we are depleting groundwater resources, etc., etc. There was an article by Mark Anderson Wilk, editor of the Journal of Soil Water Conservation, 2008, titled Rising Expectations for Conservation in Water-Scarce Times. Quote, however, availability issues have not been calmed, and with population growth projections and threats associated with climate change, the issue is expected to become more challenging and more complex in the years ahead. So here's the notes. Population growth projections, climate change. 2 words we hear a lot, especially about climate change and water. The issue is expected to become more challenging and more complex. And I say, Mark, I disagree. They can't possibly get any more complex. We are there. The fact that we're still having more people, or it may or may not be warming up, is irrelevant. The issues are there, we know them. He also said, this is an interesting, what are the realistic expectations for what can be accomplished through conventional and state-of-the-art water conservation measures applied to current land and water uses? So what are the reasonable expectations for what can be accomplished through water conservation? And my hypothesis is relatively little. And given the recent tragedy of the cruise ship around Italy, it's a little bit dangerous to use the expression that it's shifting the chairs on the deck of the Titanic. But in essence, perhaps that's what water conservation is about. We have much bigger issues. Mark also said, in what cases will conservation on its own simply not be enough? And when will significant changes to land use and human activity be required to minimize conflicts, loss, crises? So significant changes to land use and human activity. So he's saying that, whoa, you know what? Maybe we do need more. Maybe just simple conservation measures aren't enough. So, quote 2008. I also want to read something to you as well. I have little need to remind you that water has become one of our major national concerns. Farmers know only too well the difficulties that attend getting enough water for irrigation, etc., etc. They have suffered the fury of floods and the worries of erosion. Losses in life, security, productivity, and money have been great. Those problems and many more like them, you know. What have we done about them? What more can we do to solve them? We have to know where water comes from and what happens to it. We have to know how much can be used and when, and how our land practices influence its behavior. We have to stop wasting water. Anybody want to hazard a guess? What year? 1955. The year of the Book of Water from USDA. A colleague of mine that was working on the panel that we were working on, the water legislation, said that, and I think this is a misquote, but he used it enough times that it sounded good. He said, the thing we learn from history is we don't learn from history. Just a total sidebar about water. Isn't it interesting how just about every other month we find somewhere in the universe that has water or has had water? It just seems rather interesting to me. Okay, some of the qualifiers about what I'm going to say. We always need to know whether we're speaking about surface water or groundwater. They're very different scenarios. Most of this seminar is on surface water as we have far greater control of it. Now, fascinating question, is water considered to be a renewable resource? And it was interesting, if you go to the blogs of Peter Glick, you would see that he laughed when he was asked that question, because that's not an easy one to answer. Some would agree, some would disagree. Most would agree that the amount of water is finite or limited in a given location. Now, if one is short of something, you can either use less of it or get more of it. Right? That's pretty straightforward. Now, the only thing is with water, we can't really create more. But the interesting thing that I find is that most of the discussion has been about the former, that we use less of it. But what I'm going to show you in this seminar is that we actually have many ways in which we can get more water. We're actually just changing our thinking just a little bit. Water use. Water use is not always water use, because you cannot put water and oil in the same context, because it is possible to have a non-consumptive use of water and a consumptive use of water. Very different. And the whole bottom line is that after you're done using it, can somebody else still use it? That's non-consumptive, okay? Okay, motherhood. So who could possibly oppose conservation of water? Of anything, really. So who wouldn't fix a leaky tap? Who would speak against a low-flow shower head and a low-volume toilet? Those have been around, okay? The question is, what exactly does conserve mean? And I was disappointed to find, because the Soil and Water Conservation Society of America, perhaps at least a decade ago, their motto was the wise use of water and land. So we're using it, but we're using it wisely. So in that context, conservation doesn't mean we just sit and look at it. We make use of it. And of course, we could have the lively discussion about what sustainable use means. Okay, here we go. List of myths, according to me. So, if I use less water here, there will be more for someone in Calgary or Ontario. Or vice versa. No. We're here, we're here. If we use less water now, there will be more water for us in the future. Surface water perspective, operative word is more. No. Might be the same amount, but not more. Even with groundwater. Number 3, we are huge water wasters. Statistics, I think we're second in the world. Depending whose statistics, we use about 325 liters per person per day. Let's not confuse terms. The word was wasters. And my comment to you is, we don't waste water. We use it. There's a difference. There's this analogy that people have that if you take your car to drive to the local store to get bread, you're wasting energy. Well, that might be so. Because if you burn the oil in the car, it's gone. You ain't getting it back. But guess what? With water, that's not quite true. Okay, if we don't start conserving water now, we will run out of water. It's always a really good one for laying guilt trips on kids. Because it gets them thinking. It's too bad as adults we don't listen more, but anyway. Okay, we should review case studies from elsewhere to learn what we should do. And I'll give you a very, very good example of why that's just meaningless. And that's why the many books that you see, you can buy in Indigo, you are interested in reading because you'll understand what the issues are in Phoenix, Arizona. but they don't really have a lot of relevance to who we are. Okay, 6, water management is easy. Best line I heard was a little while ago, somebody said, this isn't rocket science, it's far more complicated. And that's true, okay? Here it is, the Americans are shooting a probe to Mars. I'll bet you they're fairly confident Mars is going to be there when they get there, because Mars follows certain laws. Well, water sort of does, but it has a mind of its own, believe me. Now here's really a strange one coming from me. Problems with water will have engineering solutions. The one thing we learned about past projects is that, especially if we have an engineering solution, is that we solve one issue and we create another one. And it often would be fine if it was just one that we created, but it's usually several, or else we created one that's far bigger than one we had to begin with because of narrow approaches. Okay, here's the really fascinating one. Here's one about consumptive use versus non-consumptive use. There's 250 milliliters of water in this measuring cup. That's 1 cup. Okay, we're going to consider 2 scenarios. The first one is person A. Lives in an apartment in Edmonton and has a tap that drips. So after X period of time, I will have put the beaker under and caught the 250 mils. Okay, that's A. So B is a person who lives next door, takes the same cup, goes to the tap, fills it with water, and goes and waters their plant. Which one conserved water? The interesting thing is, it's technically A. Because the water is still available. Yes, it dripped and it went down the sink, blah, 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 and it went off. Somebody else is going to use it. The moment you watered your plant, that was it. It's going to evapotranspire or something else like that. So we need to be really, really careful when we talk about conservation, whether we're talking consumptive use or non-consumptive. Okay, we get into the really interesting ones. 9, global warming means dire things for water everywhere. Dr. Daniel Schindler was here last week. He gave a seminar. He talked about his research area in Alaska. He said that projections are that the air temperature will be rising by 2 degrees and precipitation is going to rise by 30 to 50 millimeters. Interesting scenario. Okay, so got another quote from, I hesitate to call it a journal, but anyway, it's called Ag Professional, January 10th, 2012. So we're talking recent. Record yields for staple crops in the United States and globally in recent years seem to contradict fears that agriculture will be negatively affected by increasing climate temperatures, according to James Taylor, Senior Fellow for the Heartland Institute, blah, blah, blah. Since 2007, we've seen record yields in production per acre in edible beans, cotton, alfalfa, sweet potatoes, canola, corn, hops, rice, and wheat, and more. This is a long-term trend, and it applies globally too, as global grain harvests have nearly tripled since 1961. Climate is not the only factor, but even if we accept global warming as a problem, it's certainly not inhibiting crop production. Perhaps a view of one individual. Next one, climate extremes are bad. May remember not so long ago there was a huge snowstorm eastern seaboard in Washington. And the neoconservatives in the United States jumped all over that and said that, well, that was definitely an example that global warming wasn't really happening. And so Peter Glick was commenting, well, no, you can't quite do that. You can't pick one storm and say this or that. The really funny thing is that the neoconservatives took an opportunity to have a couple of cheap shots at Al Gore, and one said that it was just Mother Nature continuing to snow until Al said, "Uncle, uncle," and then it would stop. But the other funny one was that it was merely providing the building material for Al to have an igloo in Washington. But my point in this one is that Peter is correct. We shouldn't pick one event and then say, oh, this is an example of why this isn't happening. But if you think about it, the media does exactly that, but in the opposite extreme. And that is, if there's an event, for example, a drought or something, they say that that's an example of global warming. It's not quite that simple. Muddiness. So I've talked about water quantity, but water quality has become a huge factor. The whole area of gray water use is just up. The potential is unlimited. Okay, on to management. So look at the top on your hydrologic equation. Very simple. Precipitation plus irrigation is equal to evapotranspiration plus runoff plus drainage plus the change in soil moisture storage. That's it. That's rocket science. We're going to deal with it. Okay, so what I'm going to get you to do is go through with me 3 cities. Phoenix, Arizona, Edmonton, Charlottetown, Prince Edward Island. Phoenix, Arizona has annual precipitation of 210 millimeters. It's even drier than Oya in Alberta. Very little precipitation. Any of you been to Phoenix? Fascinating city. They don't have any gutters. The roads are runoff mechanisms. I'm going like, this doesn't make any sense. We have 210 millimeters and they're talking about floods. It's the irony of it. Lots of runoff. You may also remember Phoenix recently for the dust storms. Boy, those were truly, truly amazing. Just in case you're wondering, to avoid Phoenix when it rains really hard, don't go in March because it's got 27 millimeters. Okay. Charlottetown, 1,173 millimeters. And the fascinating thing is, it's amazingly uniformly distributed over the year. Interesting thing about Charlottetown is 312 millimeters of snow. Edmonton, 483 millimeters. 121 as snow. So the reason why I point those out to you is there's a wide range of issues. Charlottetown, for instance, uses essentially groundwater. Prince Edward Island, 100% use of groundwater for water supplies. A fascinating place. They're very dynamic. Coarse textured soils, high potato production, great movement of water down to the water table, great connection between water table and streams. That's the good news. Everything I just said is the bad news too, because depending on your perspective. Edmonton, 483 millimeters. And we have 121 as snow. So here it is, Phoenix has no snow, but they get the really intense summer storms. And what do you do with the water? And that will be the question that I'll follow. Okay, fearless predictions for 2050. And as I was doing that, I thought, well, there's no problem. Because everybody knows that you should never, ever make a prediction that somebody can test in your lifetime. And I thought 2050 is safe, and then I did a calculation, and I go like, whoa, there's an outside chance. I might even be around to see if I was wrong. So notice I said around, I didn't say at the university. Okay, so fabulous place to work. Okay. Dr. Bentley would be really disappointed if I didn't mention population control. For those of us that know Fred, he was a real keener on population control. So, Anybody know what the auspicious number was on October 31st of 2011? 7 billion. Excellent. And the question is, where are we headed? Well, that's a good question. If you Google world population 2050 and Wikipedia comes up, that's what you get. So where do you want to be? Okay, here are my choices. Here's the fascinating thing is this is according to the UN, it's 2004 projections. One of the projections is that in 2050, the population will be 7.3 billion and declining. We've gone over the hump and we're coming down. Okay, so the UN medium is 9 billion and almost peaked. So when you look at that scenario, the peak is going to be close to 9 billion. It's going to remain that way for 2050 to 2100. Of course, there's the UN high one that just continues on forever. And it's sort of like, and we're supposed to make some kind of projections. Okay, anyway, my whole point in this is that one of the issues that's sort of the ticking time bomb is how are we going to feed those people? Okay, here's another point of view. In 2050, the population of the world is going to be 28% higher than it is now. Let me rephrase that. In 2050, the population of the world is only going to be 28% higher than it is now. It's one thing about percentages, you can always use them and always have a big number as a base because you can make the percent look small. So the reality is, how do we feed them? Okay, look at the second part of your handout. You got 5 variables. And what I was thinking of doing is should make these into these, these magnetic little things you can stick on the fridge. Maybe do that. So you got these variables. You got carbon, economy, energy, food, and water. It's sort of the equivalent of food, fiber, and whatever else. Which are the most important? Where do you start? And it's the whole, I guess my whole point is, remember when we said this isn't simple like rocket science, this is complex? Well, guess what? Once we start to roll in food, so don't natter at me about how much people use water, tell me what they're using it for. Okay? So we have various scenarios. One could be we're using it to raise livestock. Another one is that an urbanite is using it to wash his driveway. Another one is blah, blah, blah. It's all the scenarios. We're going to have to make choices. The other thing is, notice I put carbon in there. Because what if we can use water to reduce the carbon footprint? Wouldn't that be a good use for water? Blah, blah, blah. All kind of possibilities. And what my prognostication for 2050 is that we'll finally start to talk about all of them at the same time. We'll also start to talk about best use of water in an area. So in a given area, what is it that we think water would be best used for? And coming back to the Phoenix situation, is we're going to have to somehow shift in the next little while about how we're actually using stormwater. And I'll give you some examples. Some of us are old enough to remember that at one time in the city of Edmonton, the downspouts that came off the roof actually went in the ground. And they were connected to a system that took the water away. We didn't have to worry about it. So then some years ago, the design shifted and the pipe comes down beside the house and it stops. So in our climate, the wonder of that is that it probably has undoubtedly caused thousands of slip and falls because we fell on ice that was on the sidewalk that came from the downspout. A lot of us has had to resort to rerouting the downspout. Where did the water go? Well, we sent it onto the ground. Okay, just help me here. I thought the purpose was to get more water. So why are we putting it into the ground? So that our lawns can grow faster and then we have to cut it twice a week instead of once. Okay, it's a huge resource. Why are we doing it? Oh, I know why the city did it. Because what happened in times of huge water flow, the system got overwhelmed and we were discharging sewage to the river. That's not a good thing. But maybe the solution was the wrong direction. Maybe when we need more water, we should take advantage. For example, in Phoenix, that's the part I don't understand, is you can walk along and you can find these massive, almost like channels that they've created to take the runoff water away. So you build this wonderful concrete sled thing, and the water comes along and it says yes. So from here to there, boom, gone. Minutes. But gone. Why? Why would we do that? Okay, here's another one. Pervious concrete. You got to look this one up. And you got to rush out to Home Hardware and get some. Because this is just the best thing since sliced bread. Pervious concrete pavement is a unique and effective means to address important environmental issues and support green, sustainable growth. By capturing stormwater and allowing it to seep into the ground, porous concrete is instrumental in recharging groundwater, reducing stormwater runoff, and meeting U.S. EPA stormwater regulations. Wow. Cool, there's more. Okay, in fact, the use of pervious concrete is among the best management practices recommended by the EPA and by other agencies and geotechnical engineers across the country for the management of stormwater runoff on a regional and local basis. It's brilliant. When all else fails, send it into the ground. Okay, yes. If we firmly believe that groundwater recharge is a possibility, let's do it. But they're talking about parking lots and other things where they're using this material where, again, we have a system of collecting it. We could use the stormwater. I'll get to some of the issues related to that in a minute. The future as well, to me, lies in with the issues of the 9 billion population, food, irrigation. And for the life of me, I really, really don't understand, especially in this province, the irrigation bashing that goes on. It's a complex issue, okay? But when we look at the economic driver that irrigation is in this province, 18 to 20% of agricultural production on 4 to 8% of the land. You have probably some of the best soils in the country. You have great climate. And let's assume that global warming goes ahead. It'll be even warmer. And let's assume, for the sake of my argument, that snowfall doesn't go down. You got to be kidding. That's an investment. Yeah, I know we can get into all kind of debates about what is it that we're using the water to irrigate? But irrigation is going to be, whether we like it or not, a major, major factor in feeding the 9 billion. The other one, as an Albertan, is what I perceive to be the hypocrisy surrounding the oil sands water use by the oil companies. They are licensed. They are using water. And the reason why I say hypocrisy is because we have legislated them into a corner. And that is basically they're not allowed to discharge water back into the river. And if you're talking about stuff from the super duper toxic settling ponds, that's true. That could be true. Now, let's fast forward to 2030. And think of the thousands of reclaimed hectares of land that we're going to have in the oil sands region, where's the water going to go? Is it going to go back into the river? That's the major question. Do we have a mechanism whereby we could sit with the oil companies and say, let's not talk about 2012, let's talk about 2040. And the thing is, I know there's discussions going on between adjacent companies about that, but we do have to start imagining a better world about how we're going to be using water or using the runoff in the oil sands region. 2050, I see far more reservoirs. Yeah, I know you really wanted to hear that. The fascinating thing is that, how many of you know that there's a soccer field behind the Lister complex? 116th Street or whatever it is. Does anybody know what's under the soccer field? Pardon? A parkade. Okay, so what we're going to do is, imagine this, we're going to turn it into a huge cistern. We need to store water. Okay? That's what's likely going to happen. And the other fascinating thing is that I actually see that as a huge entrepreneurial initiative. So, for example, I'm allowed as a private citizen to put up a wind turbine, generate energy, and sell it to the grid. Okay, so Francis and I are going to get together and we live adjacent to each other. We're going to get a huge backhoe to come. We're going to dig a bejesusly big hole in our backyard. We're going to put the cistern in. We're going to put it on top. We'll put a tennis court. And what we're going to do is we're going to collect water from our downspout that the city did not want. So we're going to put it into the cistern and then we're going to sell it back to them. Why not? All the things. For those of us that were raised in rural areas, we know the critical importance of land. If you got land, you can do something with water. That's the irony of it. It's funny because in my introductory course, I started to talk to the students about water farms. You know, they should start thinking ahead of investing and buying land somewhere, turning it into a water farm. Most of them kind of look at me kind of funny, but obviously the idea needs a bit of work. Okay, water pipelines and water treatment. That's going to be Francis and I with our cistern in the backyard. Yeah, depending on how we're going to use the water. But then again, you know what? Maybe we'll sell it to our neighbors and they can wash their driveways with it, which would be a good thing. Now here's the really, really touchy one. It's what I call location disincentives and moving people. So why do we continue to allow people to move where it's just tough to get them water? The projections for the southwestern United States prior to the recession was staggering. They were talking about something like a 30% growth. Like, whoa. Here's desert. Why don't we move them to the southeast where they get a heaping lot of rain? Well, maybe it's because there's hurricanes and they don't want to be there. They don't want to have to rebuild their house every 3 years. Interesting question. I still rest my case. Now here's the fascinating question. For those of you that know Calgary and know irrigation, Calgary is pushing up close, if they haven't already, to reaching the limit of their water license. So they need more water license. But the river's overcommitted. Where's the water going to come from? Well, that's a no-brainer. We'll take it from the irrigators. They got lots. But the question is why? Why do we take it from them? Go back to the variables. So there's the irrigation farmers are going to say, what are you talking about? I'm feeding the world. What are you doing with the water? Ooh, that's an interesting question. Well, maybe you're working for the Bank of Canada and you have a huge salary and taxes are good, so maybe we want you in Calgary. Okay, anyway. So anyway, wonderful discussions. Okay, here's the other fascinating thing about water is other things remaining equal, it's wise to concentrate them. So everybody in Alberta should live in Grand Prairie, Edmonton, Red Deer, Calgary, and Lethbridge. Then we can provide fabulous water service to them. Safe water. Right. Okay, so much for the extreme people. Okay, desalination. I have a vision that a grade 8 student in somewhere in Ontario, probably a female, is going to have this science project that's going to revolutionize desalination, and we're going to have all the world's going to have all the water. You know, Taylor Coleridge could not have been wrong when he said water, water everywhere, but not a drop to drink. So all we have to do is figure out how do we get the dang salt out of the water, and we got it made. Yes, right. Hey, there is. Okay, moving into sort of a more personal one. I see a time of non-complaining because we've banned it. So nobody's allowed to complain about anything unless they have a suggestion on how to fix it. Doesn't necessarily mean it has to be workable, but they have to come up with it. Okay, and then what I call management. So back to the hydrologic equation. This is what the editor said. Stresses related to decreasing water availability are likely to continue to raise the demand for water resource management based on science and professional expertise, similar to that catalyzing effect of the Dust Bowl on the soil conservation movement in the United States. Whoa. So decreasing availability is likely going to increase the demand for water resource management based on science and professional expertise. My question is, what have we been using until now? So what is it that's going to have to be different? Just because the problem gets bigger doesn't mean to say you have to change anything. The other interesting thing is that, yes, the Dust Bowl was a catalyzing event, but probably next to no people of the younger generation know about it, and they're urbanites, and if it's a rural phenomenon, who cares? Okay, here's the other one. Next one. Finger pointing. Finger pointing and struggles over rights are common responses when access to water is in question. It's not me, it's you. This document says I have the right to use the water. Buzz off. Okay, so my comment is it really doesn't matter what I think. It frankly doesn't matter what you think, but it's what we collectively can agree on. And I mean collectively. Can you imagine every jurisdiction having a group of water elders? You know, it's a council. They make the decisions. Now, we could be of the illusion that we have that now. But we don't. We have councils. We have councils of people who have vested interests. It's their own party. So we always have to be concerned about who's being represented. But what if we said these people's responsibility is to everyone? Okay, another one. Last point. Same editor said, and when will significant changes to land use and human activity be required to minimize conflicts, loss, and crises to water shortages? So when will significant changes to land use and human activity be required? And remember, it's in the context that he asked was, is it possible that water conservation just isn't enough? We'd have to do something else. And when I read that, I listen and I hear that it implies we must stop doing something. And I'm sorry I have to have one more opportunity at cheekiness. And this reminds me of the recent administration in the United States that talked about the war on poverty, as if we could have their U.S. Navy SEAL team come in and just nuke whoever was responsible for poverty and everything would be done. Well, maybe the problems are a bit broader than that. So what I'm going to do is, just to finish off, and just in my last words, is that, hey, I actually believe the glass is half full. and that we're working from there, and that is that what if I took his words and said, and when will land use and human activity be managed to provide the water needed? Thank you. Sure.
You say that the problems are bigger, the solutions have to be bigger and more integrated, but we've tried that, right? Water management styles are somewhat cyclical, aren't they? I mean, in the 60s, the solutions were, the things that they were looking at were getting bigger and bigger and more complicated. It was comprehensive river basin management. It wasn't just water use, it was agriculture, recreation, everything got beyond our ability to compute it. So now, 50 years later, we have the computing ability, but our brains still can't handle that. How do we break it down into a piece we're comfortable with making reasonable suggestions about?
Good point. I would also add that the problem often became that the models became so complex we didn't have the data to be able to run them, and that's the classic problem. I think what you're talking about has just been very common in hydrology with the oscillation between the extremely complex to let's simplify it, and then all of a sudden like, well, this is a little bit too simplistic, et cetera, et cetera. I think that's actually healthy. I'm sorry, I think that is healthy because then we stop, for example, looking at that is all of a sudden it's a 5-variable equation. Does that apply all the time? Look at the hydrologic equation. In most instances, we're looking at the situation and saying, drainage close enough to zero, boom, gone. Runoff, so, boom, gone. So we do that for each. And I think that the complexity will also be a function of the area, if the area that you're in. It's quite possible, for instance, that in some areas you can manage water for just food. Others you can't. You might be able to manage it for carbon, or perhaps both. Okay? Is that a good avoiding of your reply? Nadir first, and then.
Okay, I would like the first kind of comment, 5 set more comments about your example.
Yeah.
You gave A and B people that to say from drinking water.
Yeah.
And the B is the watering the plant with city water. And you think that was commonly used. The first one is not really wasting. Second, I have a totally opposite opinion because the first one, you have to spend energy to get back to it. The second one is not really wasting because, plants are cleaning the air, producing oxygen. That's the benefit I think I can see. And then, do you know how much energy we have to spend to clean up the 1 cubic meter of water, for example?
Thank you for bringing that up, because if you hadn't, I would have, because that's correct. But you see, what you did was, there's 2 twists, Nadir, that I would say. You brought the word waste. I didn't use the word waste. I said conserve. There's a difference, okay? And the other thing is, thank you for bringing up the energy one, because if you look at the recent publications, the pamphlets that string at people's hearts that they go home and they do something about it, it's about energy. Of course it is. Don't try to sell it that you're saving water, because that's not really what it's about. But the whole notion, it's the same thing, for example, about, people washing their driveways with tap water. So what? Well, it's because we're using treated water. Yes, Nadir, it's true. And definitely the whole energy is what the sub-driver in water is, and how much do you need. And it's the same thing, like, for example, I very calmly said that, we're going to have to treat the water, in 2050. Well, we do that now anyway, but maybe there'll be a grade 9 student somewhere that'll come up with some brilliant discovery about nuclear or whatever. And so, anyway, thank you very much for your comment. It's very appropriate. It is energy.